In the last video, we started talking about aging and memory, and we talked about two conclusions that we've reached about aging and memory. First, that age affects some memory systems and not others, episodic and working memory, but not procedural memory, semantic memory, or implicit memory. In fact, semantic memory often shows increases. And we found that individual differences within an age group are often greater than differences between age groups. The third conclusion is that age differences in memory are reduced by, but not eliminated by, consideration of non-cognitive factors. And let's talk about what some of those non-cognitive factors are that people have attributed age differences in memory to. First, there are things about internal, and there are things that are external to the individual. So here's what I'm really talking about. Is it aging that produces a change in memory, or is age producing a change in some other variable that's producing the change in memory? So this other factor is really the one that creates a difference in memory. So we have age, we include some other variable, and we see the effect on memory. That other variable might be accounting for what we look at when we simply look at age differences in memory. Now, I mentioned that it could be intrinsic or extrinsic. It could be in the person themselves, some factor that is in the individual that's causing that change in memory, or it could be something outside of the individual, some environmental factor. And we'll look at both of those and see whether or not we can account for memory changes with aging by looking at other variables. For example, maybe there's a difference between young and old people and how motivated they are to do the task. The internal motivation, which is the why for doing something, might be less or might be more. And so that could be the thing that's really producing the change that we see in memory task. Maybe it's emotion. Maybe there's more emotion about doing a memory task because I'm an old adult, and that's what's producing the change. Or maybe it's health. That's a common one. There are age-related changes in health and disease, and that produces the memory difference that we see. We know that we do better on cognitive tasks if we feel good. If we don't feel so well because we're not as healthy or we have some disease, then maybe that's producing the age differences that we see. Or maybe it's simply our own belief, a self-efficacy about how we're going to do in the task. That might be the thing which produces the differences that we see in memory, and not age itself. So let's look at a couple of these. We did a study that we looked at health, self-reported health, things like how do you feel relative to how you felt 10 years ago, or how many medications are you taking. Lots of self-rated statements about one's health, and we looked at how that influenced the correlation that we see between age and memory. Now, I'm using these Venn diagrams to show that there's some overlap here between the age variable and the memory variable, and that is, in fact, this sort of overlap that we see in these models. If we include health in this study, we found that while health reduced the relationship between age and memory, it was a very, very small overlap. Only accounted for that much of the variance over the entire variance between age and memory. So health only produced a very small overlap. So it attenuated, it reduced the age-memory relationship, but it certainly didn't eliminate it. There's a lot of variance here between age and memory that's left over, even when health is considered in the experiment. We also included some what are called fundamental cognitive variables, like perceptual speed. We earlier talked about perceptual speed as being a part of intelligence. It's part of fluid intelligence. Perceptual speed is how fast can you make perceptual judgments. And when we included perceptual speed in the equation, when we looked at that variable, it accounted for almost all the relationship between age and memory. Only a little bit was left over, so it reduced it, but reduced it a lot more than this intrinsic value of health. So primitive cognitive variables like perceptual speed or even working memory can account for a large amount of this age-memory relationship. I call them cognitive fundamentals, like perceptual speed. But health itself accounted for a very small amount of that relationship. So cognitive variables, can attenuate significantly the age-memory relationship, but health cannot. There are also extrinsic variables, things that we develop through experience, like, for example, we were born at a very different time with very different care for young children, very different educational experiences of a 60-year-old versus a 20-year-old. They just came up at a different time, and that's called a birth cohort. The birth cohort had shared these kinds of experiences when growing up, which are very different from the kinds of experiences that are shared by younger people. Or maybe it's culture. The OLI that you read about aging and memory talked about the fact that culture, the difference in Eastern and Western people, because Eastern people have a tremendous respect for older adults and Western people sort of don't, and maybe that those differences create stereotypes of what memory is going to be like when you grow older, and they show that in Chinese older adults, the differences were much, much smaller than you see with Western adults. That's a cultural phenomenon. Or it could be simply laboratory task experience. If you think about it, college students, a typical young group, have a lot of experience with taking tests and coming into a task and taking tests, but older adults haven't done that since they were in college, or if they went to college or in high school. So maybe it's just differences in the anxiety that's produced by having laboratory task experience. Maybe the age difference would be smaller if I looked at more everyday tasks, for example. So the educational experiences could be something that's very different, and that produces the memory differences, and other kinds of environmental differences. So there are lots of things that are due to experience extrinsic that might account for it. Let's look at a couple of those. First, birth cohort. The best way to look and see if birth cohort is a problem is to do longitudinal studies, where you compare the same people as they grow older. So we have the same birth cohort, that's not confounded with age, and we look at these longitudinal data versus the cross-sectional that we do when we compare 20-year-olds to 70-year-olds. The most famous longitudinal study, or one of the famous ones, is the Baltimore longitudinal study, which is actually conducted by the National Institute on Aging in their own laboratories in Baltimore. And when you look at their study, this is, for example, the cross-sectional data between 40 and 50-year-olds and 55 and 65-year-olds, you see that if I look at error, this is errors on a memory task, so it's errors on the ability to recall nouns in noun pairs that have been presented. So I might present dog, tree, and when you see dog later, you have to say the word tree. So that's a paired associate task, and here we're looking at errors on that task. And you can see that as you grow older, you make more errors. If I compare cross-sectionally 40 to 50-year-olds and 55 to 65-year-olds, I get these increase in errors due to age. Well, is it due to age? Now let's look at the same comparisons, 40-year-olds to 50, 55 to 65, in the same people. So here we have 4 different groups. Now we're going to just have 2 groups, and we're going to look at the data longitudinally rather than cross-sectionally. And what I find is pretty much the same thing. So with longitudinal studies and with cross-sectional studies, we find the same things. There can't be birth cohort. The cohort differences simply aren't there in the longitudinal comparisons. Recently, a study was published by Ronlund, Nyberg, Bachman, and Nilsson in Sweden, and they did the Betula Swedish study, longitudinal study, and they found pretty much the same thing. If you look at the ages between 50 and 60, you find that semantic memory, vocabulary, increases. They actually use several different semantic memory tests. And episodic memory, the black dots and lines, decrease. And only at age 65 and 70 you start seeing declines in both. But semantic memory is significantly better than episodic memory all throughout the task. So in early late adulthood, 60 to 55 to 65, increases in semantic memory, decreases in episodic memory, and then in late adulthood, you start seeing decreases in both. So longitudinal studies show pretty much the same thing that we find in cross-sectional studies. And also, I mentioned that maybe it's the experience with laboratory tasks, do we find age differences in everyday tasks? And the answer is yes. We can look at memory for faces. All these studies have been done. Memory for performing acts. When did you perform something? Memory for maps. Memory for conversations that you've had. Memory for TV program content. Memory for news, from newscasts. Memory for appointments. And memory for prose. In all of these, you find age differences. So in everyday tasks, as well as laboratory tasks, we find the age differences in episodic memory. Now, the final conclusion I want to talk about is that age differences on memory are especially susceptible to false memories, or memory illusions that we talked about when we discussed memory. I want to read you a quote from Mark Twain's autobiography. He says, "I have grown old, and my memory is not as active as it used to be. When I was younger, I could remember anything, whether it happened or not. But my faculties are decaying now, and soon it'll be that I cannot remember any but the latter." It is sad to go to pieces like this, but we all have to do it. In other words, he's saying he'll remember things that didn't happen as he grows old, and that's exactly what we find. You remember the false memory study that we actually did in class, where I presented a list of words: nap, bed, pillow, dream, pajamas, and snore? I had you recall them, but you could also do a recognition test where I give a list of words, and you have to check the words that you saw on the earlier list. And what we found was that more often than not, people will remember the words that they saw. That's called veridical recall, real recall of words that were presented. But they also remember the word sleep, even though it was not presented. We did a study comparing young and old adults with this, and what we found, the typical finding with episodic memory, the list of words that were presented earlier, the young recalled more of the words that were presented than the old did. But if you look at false recall, that remembering of the item which was not presented, old people had more false recall than did young people. So a greater amount of false recall in older adults and a smaller amount of true recall, veridical recall, in older adults. So older adults are especially susceptible to false memories. So let's go over now the conclusions that we reached from looking at the aging and memory literature after my 30 years of research and the research of many others. First, age affects only some memory systems: episodic memory and working memory. Second, individual differences increase with age. They don't decrease. We become more different, not more alike. Age differences in memory can be reduced by other non-cognitive factors, but not eliminated by them. In fact, most non-cognitive factors have a small effect on the age-memory relationship. And finally, older adults are especially susceptible to false memory or memory illusions. Thank you.